any 15 is voltage divider, correct? This one, we were discussing this thing, correct? Okay, so I have completed this slide or not? This one is completed? Voltage divider? No.
No.
All right. So yesterday we discussed the voltage divider formula, and I explained you. We'd also discuss some questions which basically help us to perform calculation, which easily we can find the voltage division. See guys, this is again a voltage divider application which is called potentiometer. It's a device. What basically it does, it is called potentiometer, means the output which we are getting here, we can have variable output. Yani, you can see this arrow and this resistance. Showing this arrow or this resistance means it is a variable resistor. What is that? Variable resistor means we can change its value. Okay. I have variable resistor with me. Do you want to see this? I have it with me. I can show it to you. So, all right. I need to turn on the video. Just a minute. Where is the video? Okay. So, see here. So this is a PCB, basically multi-purpose PCB, girls. Here ICs are connected. See, these are the actual ICs which is connected there, and this is a power supply connector. We can connect power supply here, 9 volt, and I'm talking about this variable resistor. So this is a variable resistor. Understand? So by rotating this one, see, we can rotate this one. So as I rotate this one, what basically happening? The resistance is changing. Its value is changing. So when the resistance change, you know that the voltage drop across that resistance will also change because of the Ohm's law. What Ohm's law says? V is equal to I into R. And we know that V is directly proportional to the resistance. So if resistor will increase or decrease, voltage will also increase or decrease. So this is something. So and there is a bulb connected here. Okay. So actually battery is not with me. Is it working with battery? So there is a problem now. So what happened when I rotate this one? So the intensity of this bulb is basically change. It's more and less. It's depend upon the current flow. And who is controlling the current? The resistor itself. So more resistor, less current. We know that one. So this is a variable resistor. See how it looks. So from the back side, it looks like that. And there is a knob to rotate and change the value of it. Clear? Range of the voltage, yeah, range of the voltage will depend upon basically the resistance itself. Okay. So see what will be the voltage range. We can find it now. I'll show you this one. So the range depend upon the resistance value, as I said. Okay, see now. So when the arrow is here, okay, let me just take this arrow and I'll show you. If the arrow is here, for example, because it can go up and down, right? Because it's a symbol, and actually I have shown you already. So when it is here, at that time, you can see if I want to measure voltage between this point, yani this is a ground symbol, girls, you know that this is ground, and I want to measure between that one. So can you tell me between this point to this point, how much is the resistor? How much is the resistance? It's just a wire. What will be the value at that time? What is the resistance at that time when the arrow is there? So from this point to this point, it's just a wire, or what we call short circuit. Yes, no, nothing. Any, yeah, and it will be zero, correct? But it will be zero. Nothing. Any, we cannot say because wire is there, right? So it is like zero at that time because short circuit always have zero resistance. Short circuit always have zero resistance. So it's 0 at that time. Okay. So now if it is 0, so can you apply a voltage divider rule in order to calculate the V out here? Yes, we can. And what will be the V out? V out will be R2 over RT multiplied by Vs. Getting point. All right. Now, when the arrow is down, so the resistance R2 value is 0, girls. So when it is 0, so you know that if you multiply 0 with any value, you are going to get 0. So at that time, V out is gonna be 0. Is it clear?
Yes.
All right. Similarly, now let's consider the arrow is here, extremely here. Yani, okay, direction should be from here to here now, up. So when I ask you girls, what is the resistance from this point to this point? So you can see entire value of the R2, whatever is 10 kilo ohm is gonna be covered this time. So in this situation, if I calculate the V out, so V out is gonna be R2, which is 10 over the sum, which is 30 multiplied by 15. All right, so it is gonna be 2 times, it is gonna be 5, so it is gonna be 5 volts. All right, yeah, Haifa, correct. So this means the output range is from 0 to 5 volts. So by changing the value of the resistor, variable resistor, we are able to change our output. Is it clear now? This is called potentiometer. All right. Okay, this is potentiometer, girls. All right. So bus they are asking what is the largest output available. I already explained to you the largest voltage will be 5 volts. Similarly, if I ask you what will be the minimum voltage or smallest voltage, that is gonna be simply 0. Yeah, yes, correct. All right. Okay, so power in series circuit. So power in series circuit, girls, is again it's so simple to calculate the power also. So voltage divider we can use here to find the V1 and V2. Once you know the V1 and V2, you can simply find the P1 and P2. Okay, so in order to find the power, you can see V1. So 470 over 800. So 470 is what? Yani V1, yani 470. Over that sum, which is 80 multiplied by 20. So we will be getting V1, which is 11.75. Now, I wanna calculate V2. So V2 is so simple. I apply this same formula, or you know that we can also say, we can also, yeah, we can subtract. Yeah, yani what is that? Voltage voltage KVL, Kirchhoff voltage law. We can also use, that is this one. So both are okay. Whatever you like, you can use it here. All right. So we got it this way. Now time to get the power. So for the power, we know the formula which uses voltage and resistor. So we can say the power dissipated by each resistor is the formula. Yes, V square by R, which is general formula, but we need to write specific, which is P1 equals to V1 square over R1, which is like that. Yeah. So just we can get it 0.29. Similarly, P2 specific formula will be V2 square over R2. So correct. Yeah, we can get this one also. So now this is the power, and if we sum it, we'll be getting 0.5 watt. This is the power actually, which is dissipated by the circuit. If you want to calculate direct, you can also calculate direct by calculating the total resistance and that one. Yani, if you want to calculate PT direct, So formula will be PT direct
VT squared
V2 square, correct,
over
and
RT.
our RT, correct. So VT is what? Basically the source, which is 20 square
20.
over 800. If you just solve it, 20 square, it is gonna be 400 over 800, which is 0.5 watt. So same, either you sum the individual parts or you calculate the separate part. Value is gonna be same. So it depends upon the question what they are asking. Are they asking this way, this way? So you are free to choose, your steps, how you are gonna solve it. All right. So this way we have done with this chapter. So let's just go through the questions of this one. Okay, let's see this one. Actually, I need to convert it into Kahoot, but it will take time. So let's take it now. So inshallah, if I get it time, so I will upload on the Kahoot also. So in a series circuit with more than one resistor, the current is C. Always same in
Same.
all.
C.
Yeah, correct. C. It will be C. Okay, see next one.
B.
B or A?
A.
A. Okay. Any larger
A.
across larger registers?
B.
B says smaller across larger register. It's about voltage. Okay. It's about voltage. So voltage yani larger register, larger voltage drop. Smaller register, small voltage drop. Keep in mind. So answer is A. C. Huh?
C.
C. Correct. Because they said the equal value resistors are connected in series. So equal yani let's consider they are R. So R plus R plus R yani 3R. So 3 times the value of one resistor. Okay.
C. More than one.
C. Yeah. Correct. More than one path. Okay. Series circuit cannot have more than one path.
A.
A. Okay. Yes, algebraic sum of all the voltages, both source and drop is equal to 0. And this law is called KVL, Kirchhoff voltage law.
Maybe B. 2 milliampere.
2 milliamperes. Yeah, it will be 2. It's so simple. Yani first you can calculate the total resistance, which is R1 plus R2, that is 12 kilo. 12 kilo.
Over T.
Yeah, 24 divided by 12, that is simply 2 milliampere. Yes, correct.
B. 4. The formula V equal Rx over RT multi VS, right?
Yes. So it is gonna be 2 over 12. 12 multiplied by, it will go, so answer is B. It will be, yeah, it's gonna be 4 volts. See, by the way, this time it is not a variable register. You can see there is no arrow. Okay. Sometime for the variable register, it is, shown arrow like that. It shows variable, but it is not. It's a fixed register. Its value is given, which is 2 kilo ohm. So output is fixed this time. Output will not change. It will always be 4, which is there.
Miss, I didn't understand how can you solve it?
This one?
Yeah.
This one is just a simple voltage divider. You can apply voltage divider because V out is what? V out is simply V out is equal to what? Yani the voltage across R2 because these lines are connected across R2. So we can also say this is V2.
RT.
Yeah, it is also V2. It's same. V2 or V out, they are same. You can see they are just wire connected here. So it's gonna be same. So the formula is same, simple, which you know already. R2 over RT multiplied by Vs. That's it. Okay, just put 2 over 12 multiplied by 24. So it will go 2 times. It's 4 volts. So 4 volt output is fixed now. We are able to get it 4 volt outputs. Why do we use this thing sometime? We have a source which have larger value, but I don't want larger value. For my appliances, I need less value. So we divide the voltage. Hope you remember one example that is not exact example, but could be considered. Like you use what do you call adapters, chargers for mobile phones and all. Though it requires a DC and AC, we'll discuss later on. But it is where you connect to the power socket, and you know how much is the voltage there in the power socket. Power socket voltage is either 110 or 220 volts. But the charger, in order to charge your laptops or this one, we need only 12 volt DC supply. So need to drop down. So this difference is actually the big difference. There we use a transformers or another division, voltage divider circuits. So we can drop the voltage here actually. So this is some example where we can use it. So hope it is clear. We'll do these things later on. Now, so it's again the smallest output they are asking. Yeah, it's gonna be 0 because it is a variable this time. And if arrow is down, yani at that time R2 value will be 0. When it is 0, so V out or V2 is gonna be 0. All right.
D.
Sum of
the power in all resistor.
Yes, correct. We have seen already these things earlier. So it is basically a sum of all the parts. It's not an average. It's not a smaller and larger. It is a different thing. Power in small resistors. So it is what? Sum of power in all resistors. Correct.
Doctor.
Yes.
Could you please read question number 8? Why it is 0?
Why it is 0? I already explained to you, this is a variable register because arrow is here, which is saying it is a variable register. Okay. When it is variable, I already explained that variable means its value can vary between 0 to 10K. How it is gonna be vary? Because of arrow will move. It can go up and down. When it reach here, at that time, what is the value of R2? I already told you, R2 yani this is the wire which is at that time connected between V out. So here is what? This is a simple short circuit, and short circuit always have resistance 0. So at that time, the value is 0. Okay, getting point?
Okay. Yeah, I get it. Thank you.
Yes. Output voltage is always 0. Yeah, greatest will be 7.5. Yeah, correct. Yeah, because you know why it is 7.5? It is because both resistance are of equal value. It means it is gonna be divided equally. So 7.5, 7.5, just it, that's it. And 0 because of even it is go down, so minimum value of this register could be 0. All right. Okay.
D. The voltage difference
between point A and B. Yes, correct. It is D. So it is a voltage difference between A and D. It is like that. All right. Let's see one more question, which is here. So these are the problem here questions which you can get it. Answer of 9. What is the answer of 9?
D.
It's a D, Jana. Okay. See, so there are some already good questions which you at least must go through all and practice, which is 13, 14, 15, 19, and 20. You can just check it from the book and see this question. How can we solve? This question is having multiple sources, girls. This time you can see multiple sources here. So they are asking what is I. Calculate the I. How you are going to calculate?
It will be I equal 12 plus 6 over 40 plus 20 plus 20 plus 10.
Okay.
Right?
Correct. May I know why did you add 12 and 6?
Because both are voltage.
Okay. Both are voltage. Just because of that. Any other?
Because it's a voltage in a series.
We have to use the total voltage.
Okay. What if this polarity is positive, this polarity is negative?
We will subtract.
So this is not the correct answer, which is I received earlier, that both are voltage, so we just add them. No, you add them because their polarities are like that when I am going through clockwise. So negative positive and negative positive. So it means voltage this time adds negative positive negative positive. Yani negative positive negative positive. So they will add this time. Getting point? Negative positive negative.
Yes.
Add. If you remember, I told you consider the first sign always. So signs are similar. When signs are similar, it is gonna be add. It's like that actually. Okay. So this is the way. See, also here you can apply KVL. Do you remember KVL, Kirchhoff voltage law? Yeah, answer is correct this way. 12 plus 6 over the sum of all. So you will be getting correct answer. Yani I can say I is equal to 12 plus 6 over the resistances, which is 30 and 60, which is 90. So 18 over 90, I will be getting the answer 20 ampere or 200
milliampere.
Milliampere. Okay. So answer is this one is okay. Yeah. So we can also apply here KVL. What is that? Kirchhoff voltage law. And it is what it says that algebraic sum of all the voltage drops, okay, is equal to drop and sources including is equal to 0, or what we can say, the sources is equal to the drops, the sum of all the drops. So that is also considered. So we can also use it. So see, as they said, this is the clockwise direction. So just keep noting the first sign, like the first sign is negative, so negative 12. First sign is positive, which is how much? It is gonna be 10 multiplied by I, because this is what voltage, this is also voltage. V is equal to I into R. So R is given, I is unknown. Similarly, plus 20 into I, negative 6, plus 40I, plus 20I is equal to 0. This is voltage KVL, Kirchhoff voltage law. So here we can just simplify the numbers, which is that one and that one. And what is that? Minus 18 And by the way, I can write minus 18 when it will go to the other side of the equal, it will become 18. So now I will just add i's, which is 10i, 20i, something like that. So it is gonna be 90i, and I will be 18 over 90, which will give me 200 milliamps. Got it?
I have a question.
Hmm.
The previous method, why we put 12 plus 6?
Previous method, why we put 12 plus 6?
In the
Okay.
voltage.
Okay. Any other question? That one only? Okay. So if you remember this slide, this one. So I told you, when we are moving up to down, we always consider the first sign, as I told you. So positive, positive, positive. So what I told you at that time, positive 9, positive 9, positive 9, positive 27. Remember?
Yes.
Okay. Same rule is there, but apply the same thing there. Look. What is that? So now we are going negative, positive. Okay, this is negative, positive sources. So it means negative 12, negative 6, correct? But
yes,
if you look, you also know that the sources is equal to the drops. Sources is equal to drops. Or if you are just applying KVL in a loop, you just keep applying the same way. So see the sign. Here the sign is negative, here is positive. It is gonna be changed across the register. First will be positive because the direction is given clockwise this way. So it is when I consider it, it will be like positive what? V1, positive V2, positive V3, positive V4 is equal to 0. Or I can also say V1 plus V2 plus V3 plus V4 is equal to 18. When I bring this one another side, because this is equal to this one. That's why this is a negative if you look, and this is all positive because this is source. This is what they are consuming, the energy, basically voltage drops. So this is something like that. That's why I add, because their signs are same. Clear
yes,
now?
yes, thank you.
Okay. Sometime if I change the battery, for example, if I make it positive and make this negative, now picture change.
In this case, we subtract?
Yes. In this case, I will be 12 minus 6 over 90, yani 6 over 90. This will be your answer. No, it will be not minus 12 plus 6, Mariam, because the reason I told you, when you are considering the current, through the battery, if we are considering like that, yani it is flowing negative to positive. So consider that is as a positive, because when you equate, yani drop is equal to sources. So at that time, negative to positive via battery, consider as a positive. Consider as a positive. But when same happening with the source, any resistance, consider as a negative. That's why I write here the equation. That is the main straight point rather than these shortcuts. These are shortcuts. I don't like this one. For me, just apply loop method, which I just apply KVL, Kirchhoff voltage law, and you see that we got it the same way. Same, if I apply here KVL the same way, if it is positive, negative, you will see negative 12, positive V1, positive V2, then what is that? Positive 6. then positive V3, positive V4 is equal to 0 because it is equate to 0 now. Understand? So when I bring this and this another side, so it will be written as 12 minus 6. This is the way. Okay. All right. See one more interesting thing. Rather than changing this one negative positive, if I change positive negative, this one now. See this time what will
We will
happen.
subtract.
Okay. But as per the sign, I told you, as per the sign, if you write it now, so plus 12, plus V1, plus V2, minus 6, plus V3, plus V4 is equal to 0. When I bring this one another side, you know what it will be now? Yes, it is gonna be basically minus 12 plus 6 over 90, yani minus 6 over 90. So this time current will be negative value. What does it mean having negative value? It means is that opposite direction of the current flow. Yeah, because the current they said it is flowing clockwise, but the actual current will flow anti-clockwise or counterclockwise. Is it clear to all of you? Why 0?
Yes.
Batul, which 0?
Yes, clear.
Batul.
Kirchhoff's law.
Yes, Kirchhoff voltage law. This is KVL. In short, we called KVL. All right, guys. Okay. See, I think because I told you today we are going to finish this chapter and we will not discuss again and again. See this one. So I open the book. This is the book. And in the book, they consider the direction this way. But considering the direction, it is not a matter of flow of current because the value is gonna be same. See, as I told you, I always consider that because this is negative, this is positive, girls. Okay. For me, what I learn, I always consider that if, for example, direction is not given. So I always consider the current is flowing this way, yani negative to positive via battery.
From
Okay.
negative.
Yeah, negative to positive. I studied this way, yani. Okay, but when it enters to the basically into the register, whatever direction is here, it is gonna be opposite here. See, because the first sign is positive, it is gonna negative, it is gonna be positive here. Reason should be clear to you because this is source and this is consumer. So they are consuming the voltage basically. That's why their signs are different. Understand? So whether whatever is the direction of the current, they are using counterclockwise or you use clockwise, answer is gonna be same. Keep in mind, answer will be same always. So if for example, if I wanna assume this way, which I assume, so I will be writing equations like that, minus Vs, understand, plus 1.2 plus 5.6 plus 1.2, because all the drops is gonna be add. It's so simple this way, is equal to 0. It is like that. Understand? So now the current is given already 1 milliampere. So what I need to do simply Vs, because it's minus, it is equal, everything will go another side now. I can just add it. It is 1.2, it is 1.2. For me, it is 2.4. 2.4 will make it 8. 9.5 will be like that.
9.5.
Yeah, and by the way, see, I cannot write 1.2 only. It should be I with that because it is a voltages. Okay, I just forget to include the I. So it is what? If this much of I. Okay, now, so I will, I already know I is given to me. How much it is given? 1 milliampere. And by the way, this is in kilo, this is kilo, this is milli. You know that it will cancel each other, kilo and milli, because they are in multiplication. So answer is simply 9.5 volts. Clear, girls? Okay, yeah, let's see a few more examples. See this one. I think we have this example in my slide. I already given to you this one. All right, same. Okay, this is series connector here. For example, necessary to limit the current LED to prevent the LED from the burning out. The circuit shown basic application where is a red LED is used to indicate as part of the more complicated circuit. The rehosted. The rehosted, okay, the word is there, rehosted, just to clear. Rehosted means variable register. Okay, it is called rehosted. That's the picture which I showed to you today. That is called rehosted also. Yani saying variable register. We also call that one rehosted. All right. Okay. You can just read it and okay. See now. So they are asking value of the current here, ambient current and all. Solution is already there. I am just looking for some of the questions. See now, like girls, I showed you this example and told you, do you remember the torch? And how do we connect the torch? We put the batteries over there and see how we are connecting that one. Positive, negative, positive, negative, positive, negative. If it is like that, so it is gonna be add. You know, it is gonna be add. Yani 3 battery will make a larger battery with this specification. This is something like that. So this is something else, okay? Also see a few examples here. What is the total source voltage in this figure? Can you tell how much is the total source voltage here quickly? Yes, so it is gonna be 6 plus 6 plus 6, yani 8, 18, yeah. So they are because negative, positive, something like that. That is something. So examples are there and they are explaining very well. So this is a power supply they're showing here, reading and all. So you will see more these pictures in the theory. This is also some examples. How many 12-volt batteries must be connected in series to produce 60 volts? Draw a schematic that shown the battery connections. So how many 12-volt batteries must be connected in series to produce 60 volts? What do you think? How many batteries we need? 12-volt batteries in order to get it. 5. And they are also asking, draw the schematic. Schematic, yani the design, how it should be, look like that. So the design schematic we can also draw. That's so simple. What is that? Larger, short. Then larger, short. Getting point? Okay, just a minute. I'll draw it again. Like this. So larger, you know, the larger meaning is what? This is positive, negative, positive, negative, positive, negative, positive, negative, like that. So this will be, sorry, 12 volt, 12 volt, 12 volt. They will be connected in series in order to get it. Okay. So something like that. You can get it from here. Kirchhoff voltage law, girls. This is Kirchhoff voltage law. They are showing here pictures. You know, this book is very good with colors and all they are showing here. So it is positive, negative. So current is flowing this way, resistance is connected. So V1, V2, V3 is Vn. This is Mr. Kirchhoff who give this law, and we are studying bus. And see, this is something look like, you know, practical way. We are connecting a battery, we are connecting a resistor. See, if you wanna measure the voltage across the resistor, we need to connect parallel. This is called parallel. See, because this point this point we connect across. So this is the voltage. This will give us voltage. And if I connect here and here, so actually we are connecting to this battery. It is same connection from here and connection from here. So it is giving total voltage. This is giving voltage across the resistor. So this is what we call parallel connectivity of the voltmeter. So voltmeter always connected in parallel. If we want to measure current, we need to break somewhere. Yani, let's suppose we need to break this wire from here, cut it from here. When it cuts, now I can connect ammeter so that it is become a series connection. Then I can connect here ammeter. Okay, so that current will flow this way, then inside, then it should pass through it, then it will measure it. So we cannot connect ammeter as a parallel like it is connected. So you will learn this one in lab. Okay, more questions. This is again simple. Determine the source, you can easily calculate. Determine the unknown voltage. Okay, this one is there already in the slide. Okay, unknown voltage KL, you already calculated that one. What is that? Find the value of R4. Okay, this one. Okay, look, how can you find the value of R4? Unknown resistance R4. All resistance value is not given, all given, but R4 not given. So how can we get it? R total, but how do you know the R total?
We will add the R's, the R1 and R2 and R3.
Mm-hmm.
And then we will subtract R4 from them. And we already have the I, so we'll have the law that says I equals V over R.
Mm-hmm.
And therefore R is going to be the only unknown variable we have.
So if you say V over R, sorry, V over I, what it will give you? Vs over I, what it will give you? Which value it will give?
No, I meant V over the R4 plus the sum of R1 and R2 and R3, which will give us RT.
No, so I in order to get the RT, you should know R4 also, which you don't know. It is not given this one, huh?
Yes.
So what should be your first step?
My first step is to get the RT.
RT, correct. RT, don't say R, RT. So first step must be to get the RT, yani total R. And how can I get it RT?
The sum of all
V
R.
over I.
How can you get sum, dear? Because R4 is unknown. You can get it Vs over I. Getting, Haifa? Once you know the RT, then you can apply the formula for the total. So first we need RT, which we can get it this way. So it is there 50 over 10 milliamps, which is 5 kilo. Get the point? Yeah, or 5,000. Now you can say RT is equal to R1 plus R2 plus R3 plus whatever, R4. Now unknown is R4. So R4 will be 5,000 minus. What is the minus? Which is the sum?
The sum of R1, R2, R3.
Yes, 470 plus 1,000. This way. Clear? Then you can get it. So steps should be clear. You know, it's so simple. It's not difficult. But yeah, this way. So first thing, we can get RT. Then we can apply the series resistance formula. Then we can calculate. All right. So it's there already. Solution is there, by the way. My aim to show you this one here so that you may know that how how good this book is basically. So you can see and you can easily. Okay. All right. Few questions also here. They are written asking voltage divider. So book is very well written. Inshallah, you will enjoy because colors are there, colorful, and you can easily understand. Voltage divider formula they are asking here. Apply this one. Okay, so this is a general formula. They said Vx is equal to Rx over RT. What does it mean? Yani if I want to know voltage across any register X, so X will be up and lower will be the total. Just a general formula. They just write this way. And just asking some more questions. So few more here. Very good examples here. Here, see, determine the voltage between the following points. So we already considered this example. All right, and potentiometer. See, girls, I show you today something. This is I show you the potentiometer. When I vary it, the value change. Basically, so it is like a variable resistor. Yani when I rotate this one, this rotor is what basically the 0.3, which will go and up and down, and which will change the things basically. So this is something more detail about the potentiometer. Okay. And this is again examples. They are connecting and showing with the voltmeter. This is voltmeter connected here. So as we are varying here, how the voltage is varying here. This is something. Okay. Right. So they are also telling here the applications. What are the application of this potentiometer? So application is here. We use these here. So more detail, inshallah, you will get here when you go through the book. I believe that everyone is having this book, correct? Yeah.
Yes.
Yes. So I already shared to your group leader and believe everyone is having. It is about the powers. So all the powers are there, girls. Okay. So see few more questions. There with the negative, I don't know, we are not teaching this point with the negative and positive, so you can skip it for now, okay, because they are connecting here in the middle, so we are not teaching this point, so just leave this point only. Measuring voltage with respect to ground, you can just skip this one, maybe confused later on, so just skip that one. Okay, yeah, see, this is something more practical, girls. So this is breadboard and this is resistance connected in series. So how we are going to check the voltage across it? Across yani we need to connect it parallel. So they are explaining very well. So it will help you not only theory, it will also help you the practical concept. Understand? So this is something. So with respect to ground, these type of questions you can leave for now because I am not sure other teacher is teaching or not. They are not teaching, so we can leave it. This one. Short circuit. Short circuit means what? Yani connecting a wire between 2 points. So if I join a wire between them, it becomes short. So one property of the current, girls, current always follows least resistive path. So if current will, so what happening here? The current is flowing like that. See, because there is no way. But in this situation, when I connect a wire from here to here, what will happen? Current will flow, then it will reach here. Can you tell me where it will go now? This resistor?
No, the shorter wire.
Just a short wire. It will go this way, it will bypass the resistor. So no current will go in this resistor because of the property of the current. It always follows least resistive path, least resistive, where the resistance is less, and the short circuit have zero resistance. I just explained to you, zero resistance. So all current will pass through, and here the drop will be zero because no current, zero current. Here is drop will be zero, no current. Understand? So few basic things you will learn from the book itself. So try to learn from the book if you really want to enjoy this course. Passing, not passing, or getting grade is a different thing. But having a knowledge of a subject is a different thing. So it is very interesting if you go this way. So this way we have finished this chapter. I did not start new chapter because just leave it for today. Next week we'll start next chapter, inshallah. So this way we can finish. Seagulls, here are the true false questions, self-test questions, and a lot of advanced practical, questions are there. See, so mashallah, it is very good. And I believe during your weekend, you can give 1 hour to this course to complete all the maximum questions which you can at least solve here. Then we'll start new chapter, which is chapter number 5 next week, inshallah, parallel circuits. All right. So for today, it's okay. Inshallah, next week. What is this, Manar? Office hour, it's office hour actually, this everything is online nowadays. So whenever you people, office hour is already mentioned in the my course syllabus. It is, I think, Monday, Sunday or Monday. I mentioned there 9 to 11:30. So it means, like whenever you need it, you just send me an email. That time I will be available, inshallah. Okay. First, try yourself, practice yourself. Then time no matter. You know that everything is online. I am available, inshallah. All right. Okay, girls. Inshallah, we'll meet next week and we'll continue with the new chapter. But before that, please, chapter 4 up to chapter 4, all concept must be clear. Okay, I can see 35 students. I believe all are present.